let me give you the next question. The figure I'll give you, it's like this. You have a curve C. This is from 0 to 4. This is the region marked R. This is the x-axis and the y-axis. So here C is the curve and R is the region bounded by the curve C, x-axis, and x is equal to 4. This line is x is equal to 4. We are asked to show that this area of R of this region is given by integral 0 to, what is that? 8 minus 8 cos 4t plus 48 sin square t cos t dt. We have to show that the area of R is given by this. Okay, so let us start with. Here we are given the parametric equation x equal to 8 sin square t. Okay, so when we are calculating using parametric equation, let us find the values of t from this. So when x is equal to 0, here we have given the limits from 0 to 4. X is from 0 to 4. So when x is equal to 0, 8 sin square t is equal to 0, or sin square t equal to 0, which implies that sin t equal to 0 or t equal to 0. So when x is equal to 0, t equal to 0. Next is when x is equal to 4. When x is equal to 4, 8 sin square t equal to 4, or sin square t equal to 4 over 8, which is equal to half. Therefore, sin t is equal to 1 over root 2. We have taken it the positive because we are given that 0 less than or equal to t less than or equal to pi over 2. The value of t, the range of t is between 0 and pi over 2. So we are considering only the t in between 0 and pi by 2. So the value of t is equal to pi over 4. So now we can calculate the area. So area is equal to, from here we are calculating R. Area R is equal to integral, instead of 0 and 4, we are replacing it with 0 and t is equal to pi over 4. So t is equal to 0 to t is equal to pi over 4 we are taking. So R is equal to 0 to pi over 4. Y is equal to, we are given y. Okay, we have to write it as y dx over dt times dt. See, when this dt cancels, it becomes y dx. Since we are taking it with parametric equation, we have written it as y dx over dt times dt. Okay, now this is equal to, what is the equation for y? This is equal to 0 to pi over 4. Y is equal to 2 sine 2t plus 3 sine t. Okay, now what is dx over dt? X is 8 sine square t. So dx over dt is equal to 8 is a constant. I put it outside. Now sine square t. Sine square t is equal to 2 sine t times cos t. I have taken u is equal to sine t. If so, substitution will give you like this. So this is equal to 16 sine t cos t. Or else simply I can say this in a very simple way. I'll tell you this. See, what we have to do is find d over dt of sine square t. I'm comparing this with the power d over dt of x to the power n. That we have already proven. X to the power n, d by dt of x to the power n is equal to n times x to the power n minus 1. The same thing I am using here also. So what happens? D by dt of sine square t is equal to power is 2. So 2, here instead of x, I have taken sine. So sine t. Since instead of x, I have taken sine, I have to multiply it with its derivative. The derivative of sine is cos. So d by dt of sine square t is 2 sine t times cos t. So instead of this, I can write 16 because I already have an 8 over there. So 8 times 2 is 16. So this is 16 sine t cos t dt. So the next thing I have to do is I have to arrange this to such a form. Okay. So see, when I multiply each term, I can get this as, see, 2 times 16. So that is equal to 32 sine t. I have a sine 2t and a cos t. I have the integral 0 to pi over 4. Okay. So I multiplied the first term now to the second term plus 3 times 16, which is equal to 48. What remains is sine square t. I have sine square t cos t dt. Now, if I take a 2 from this, and I rearrange, I have to get it is of the form. So 0 pi over 4. I write it as 16 times 2 sine t cos t sine 2t plus 48 sine square t cos t. This I am not changing much because I have to get a term like 48 sine square t dt that I have already got. I am keeping it as such itself. I am only making some calculations in the first part to make it like this. So this is now integral 0 to pi over 4 2 sine t cos t, which is equal to sine 2t. So sine 2t and here also 1 sine 2t. So this is 16 sine square 2t plus 48 sine square t cos t dt. Now for the next part, see, I have to replace this sine square 2t with cos 4t. I have to get it as cos 4t. So what I'm going to do is that we know this cos square, I'm taking 2t. So cos square 2t minus sine square 2t is equal to cos 4t because cos square t minus sine square t is equal to cos 2t. Since I have taken 2t, it's 2 times 2, which is equal to 40. This is from the basic equation like cos square theta minus sine square theta is equal to cos 2 theta. This is the basic equation. Instead of theta, I have taken 2t. So cos square 2t minus sine square 2t is equal to cos 4t. See, here what I want is sine square 2t. So I'm replacing this cos square again with sine square. So 1 minus sine square 2t minus sine square 2t is equal to cos 4t. Or this is equal to 1 minus 2 sine square 2t is equal to cos 4t. From which I can write 1 minus cos 4t by 2 is equal to sine square 2t. So this is now integral 0 to pi over 4, 16 times 1 minus cos 4t by 2. This 2 and 2, 16 gets cancelled. So this is now 8. So this is 8 times 1 minus cos 4t plus the rest, sine square t cos t dt. See, when I multiply this, I'll get it as integral 0 to pi over 4, 8 minus 8 cos 4t plus 48 the rest. See, if I compare this to, I've reached almost the answer. What difference is that? I have to take a is equal to pi over 4. Okay, so now in the second part, we are asked to do the actual integration to get the exact value. So now we are going to integrate this to get the exact value or the value of r. So r is equal to integral 0 to pi over 4, 8 minus 8 cos 4t plus 48 sine square t cos t dt. Now we are going to integrate this to get the exact value. That is what is asked in the second part. When I integrate, I can get this is equal to integral, not integral, I am going to integrate. So this is 8t. Integral of 8 dt is equal to 8t minus 8 integral of cos 4t. That is sine 4t, and I have to divide it with 4. Instead of sine t, I have taken sine 4t. So I have to divide it with the derivative of 4t, which is equal to 4 plus for the next, let us do it separately and then put the answer. The next term is 48 sine square t cos t dt. Here let me take u is equal to sine t. If u is equal to sine t, then du by dt is equal to cos t. So this is now integral of 48 sine square t cos t dt is now 48. I can take outside because that is a constant. And this I can replace with u square du by dt times dt. So this is 48 integral of u square, which is equal to u to the power 3 over 3. So this gets cancelled. This is 16. So this is now 16. U is sine. So sine cube t. So I can replace here. This is now 16 sine cube t between 0 and pi by 4. Now let us give the values. So this is 8 when t is equal to pi by 4, 8 times pi by 4 minus 2 sine 4 pi by 4, which is equal to 4 and 4 gets cancelled, which is equal to sine pi plus 16 sine cube pi by 4 minus this term's 0. When t is equal to 0, this becomes 0. And here, this becomes 2 times sine 0, which is again 0. And sine 0, again 0. So this is the only terms we have to consider. So this is equal to 2 pi minus 2 times sine pi. 2 times sine pi is equal to 0. Sine pi is 0, so 2 times sine pi is 0 plus 16 times sine cube of pi by 4. Pi by 4 is 1 over root 2 cube. So this is 2 pi plus 16 times cube of root 2, which is equal to 1 over 2 root 2. So this is now 2 pi plus 8 over root 2, which is also equal to 2 pi plus. I can write this 8 as 4 times 2. 2 is root 2 multiplied by root 2. So that root 2 and root 2 cancels. So this is now 2 pi plus 4 root 2. Is this clear?
How did you get 8 over root 2 to plus 4 root 2?
This thing. Okay, I'll show you that. This is equal to 2 pi plus 8. I can write as 2 times 4, right? And a denominator is root 2. What is 2? 2 I can write as this is equal to 2 pi plus 2 I can write as 2 root 2 times root 2 or square of root 2 is 2 times 4 sorry, over root 2. 1 root 2 gets cancels. So what remains is 2 pi. This is equal to 2 pi plus 4 root 2. Is this clear now? Root 2 times root 2 is 2 or the square of root 2.
Yeah,
Root
thank
2
you.
square is 2. Okay.